The Netherlands is the second largest exporter of agricultural products in the world, despite being only a little bigger than the state of Maryland. How does a country this size even come close to the U.S., the world's top exporter? By devoting more than half of its land to farming and focusing on high-value goods like eggs, meat, cheese, tomatoes, and peppers, we are excited to announce the launch of the new regional headquarters, which will allow us to better serve our clients. The country pioneered greenhouse growing and now uses robots and algorithms that predict yield, optimize water use, and can even tell when a tomato is ripe. But its position at the top is being threatened. Soaring energy prices, labor shortages, and new rules limiting pollution are squeezing the industry. So how did the Dutch become a global agricultural powerhouse? And what can its model teach the rest of the world about how to grow more with less? In the 13th century, nearly a fifth of what is now the Netherlands was underwater. So the Dutch built dikes to hold back the sea and pioneered the use of windmills to pump out the leftover water. Over centuries, a complex system of pumps kept low-lying land dry, and from this reclaimed land, small family farms fed the country. But that all changed during World War II, when Nazi Germany took over. In 1944, Dutch rail workers went on strike, and in response the Nazis cut off food supplies. He subsidized important agricultural products and merged farms into bigger, more efficient ones. Public investment in research and education transformed Wageningen University into the country's secret weapon. Its research has been used in over 150 countries. Over the years, it has spun off dozens of startups. It all started in Westland, an area just outside of Rotterdam, with one of the world's largest concentrations of greenhouses. After dark, they light up the horizon in orange, purple, and green hues from the powerful lamps used to speed up plant growth. Here, Margriet Loya runs a third-generation tomato farm called Loya Kwekers. In these greenhouses, plants can grow a foot a week. Margriet's team prunes, wraps, and lowers each one by hand. Oh yeah, then you will get the jungle. The Netherlands exports more than 900,000 tons of tomatoes a year, despite having a climate that's naturally too cold and rainy for these warm-weather fruits. While high-tech solutions help them grow faster and year-round, they still need bees to pollinate every plant. When they're not pollinating, they live in these bee hotels. Overhead, LED lights mimic the sun and create optimal summer conditions year-round. Watering these plants have also become more efficient. Over the last 2 decades, greenhouses have reduced their water usage by as much as 90%. The PVC pipes direct the water flow precisely to the base of the plants. This prevents waste and ensures optimal hydration levels throughout the greenhouse. While tech has optimized much of the growing process, humans still pick tomatoes better than robots, which struggle to see the fruit through these dense vines, ready to be harvested when the last tomato, this one, is completely red. For example, these two are just perfect, and workers follow this chart to harvest tomatoes at peak flavor. Because Louis only picks right fruit, it has a small window to get it into cold storage before it spoils. Today the tomatoes came. We packed them in the night shift, and tomorrow morning, Everything goes away with trucks. We are checking for the size. It must be between 47 and 62 millimeters. If you see like this here, you missed one tomato. It's not so nice. Robots do a lot around here. This machine on the main factory floor helps sort out tomatoes that are too small or too yellow for the premium brand. The machine utilizes advanced optical sensors to identify and sort the capsules. This automated process ensures maximum throughput with minimal error. Then workers package them by hand at these stations, so they're ready to ship out. Welcome to the future of agriculture. Here in our state-of-the-art facility, we're growing the freshest peppers with 90% less water. Every year, VD Holland grows 85 million peppers. Like tomatoes, these peppers are grown hydroponically, meaning not in the ground. There's a little layer of glue on top of it, and insects tend to pull toward the color yellow. Together, these innovations have allowed Dutch growers to achieve yields 12 times higher than the average pepper farm globally. Since 2007, the company has also used automated carts, guided by wires in the floor, to move harvested peppers from the greenhouse to the processing hall. On the packaging floor, AI-powered cameras take pictures of each pepper, comparing the images to a database of ideal fruit. This machine drops nearly 400 pounds of perfect peppers into each crate. Producing and packing all of this food requires a lot of energy. Greenhouses across the Netherlands use nearly 107 petajoules, enough to power more than 2 million homes a year. And not everyone's happy about this. That's why Dutch growers are trying to change how their farms are powered. Until recently, much of their energy came from Russian gas, but the war in Ukraine forced the Netherlands to cut off imports. Lue already had its own power plant on site. Heat from the energy-producing process actually warms the greenhouse. 50% of the heat demand is generated using geothermal energy, with 50 from microcondenser energy. With that, our gas consumption has been halved. I'm kind of proud of that. Wageningen University is working with growers to reduce their energy consumption. Without light, there is no plant growth. Custom LED light recipes have helped farmers grow strawberries, cucumber, and asparagus faster. The question is, can we make as efficient use of the LED lighting as possible? That now he's studying how LED light color, intensity, and timing can influence growth and lower energy bills. This experimental setup utilizes a closed-loop hydroponic system. We are seeing remarkable growth rates by precisely controlling the light spectrum and nutrient delivery. In this lettuce trial, his team figured out that by increasing the light intensity in the final week before harvest, they can raise vitamin C and sugar content and extend shelf life. Achieving the optimal balance of light is crucial for these plants. Too much or too little can drastically alter their growth cycle. In another room, his team is working with the Singapore Food Agency on bok choy. Here I can choose any condition. If I give them low light and a low temperature, they will grow slowly. By adjusting temperature, CO2, and light, they can speed up plant growth. These LEDs allow us to fine-tune the spectrum, dramatically improving crop yield while cutting energy costs by 40%. But it has to be the perfect balance of red, blue, and white light. For example, this bok choy likes a little more white light. These specific wavelengths of red light are absorbed by the phytochromes, signaling the plant to accelerate growth and optimize resource allocation. Here you can see that there is a chamber that can be clipped on the leaf, and then, because the chamber is transparent, the leaf can still receive the light. And we are able, through the machine, to actually see what is the rate of photosynthesis. If the photosynthesis rate is higher, then perhaps the plant with the same amount of light can grow more and faster. She's also trying to reduce water use. Swapping in different kinds of growing bases for tomatoes can help with that. They're also studying how more robots can help reduce labor costs. The integration of AI and robotics allows us to optimize the harvesting process, ensuring every plant is handled with care. Much of what's discovered at Wageningen ends up back on farms like Louis and VD Holland. This grant money isn't just about keeping the lights on, it's about the future of sustainable agriculture. We are on the verge of a breakthrough right here. It dates back to the post-war era, when the Dutch government encouraged researchers and farmers to work together. My father's study club was really important to him. He loved intellectual discussions and the camaraderie. It shaped his perspective significantly. By focusing on these key areas, we're not just anticipating the future, we are actively creating it together. Netherlands is Europe's top exporter of meat, raising 4 million cows, 13 million pigs, and 104 million chickens every year. All that livestock, especially cows for beef and dairy, comes with a high environmental cost. And it's not just carbon emissions. The bigger issue here is ammonia, a nitrogen-rich gas released from fertilizers, manure, and urine. In 2017, the Netherlands emitted more ammonia per hectare than any other European country. Why? Because it has the highest livestock density on the continent. Environmentalists say this type of pollution is stressing the native ecosystem. Excess nitrogen means tall, fast-growing grasses overtake more delicate native species, and it causes algae blooms in waterways. To cut emissions, the Dutch government started buying out high-emitting farms, but calls to limit these emissions have triggered mass protests across the country. It's our right to exist. I hope to continue farming, but then the rules must be adapted. Otherwise, it will not be possible. One place trying to find a solution is Wageningen's dairy campus. This is not a commercial dairy farm. It's a research center. We can run trials where we separate the urine and the solids. They've also experimented with robot cleaners, but each one costs nearly $30,000. So, can we feed cows in such a way that we have less ammonia emission or less nitrogen losses? They're testing different feed combinations with the help of AI-powered troughs. They've already found that replacing fermented grass with maize or fresh grass helps cut methane emissions. And when they lower protein and nitrogen levels in the feed itself, the cows will release less ammonia. Researchers are also using AI to track cows' health. The Netherlands turned its flood-prone country into an agricultural powerhouse and exported that knowledge around the world. The interconnected challenges of climate change and conflict are driving unprecedented levels of food insecurity. Addressing global hunger requires systemic change. He points out that half of the calories humans eat come from crops that are grown outdoors. Wheat, rice, and maize account for more than 50% of the world's caloric intake. That's why focusing on their sustainable yield is absolutely critical, and simply because of financial requirements. That is a sci-fi scenario that is promising, but we're not quite there yet. The farms of the future will have to rely on more than just tech. They'll need water, seeds, energy, local knowledge, and adaptable systems. So the solution we developed integrates seamlessly with your existing infrastructure, immediately boosting efficiency by 15%. Jonas is now building AI tools that can give farmers early warnings of seasonal forecasts, fine-tune water use, and more importantly, connect growers across continents. Maybe the real Dutch export isn't tomatoes, beef, or robot harvesters. It's a mindset, one that values collaboration over competition, and policies that drive efficiency. The Dutch can't feed the world alone, but they've forever changed the way it feeds itself. The Dutch can't feed the world alone, but they've forever changed the way it feeds itself.